Hello, we will now go through 8b. Okay, so for 8b, they want us to prove that OBT is collinear. Okay, and we have discussed before how collinear, first criteria, okay, is to prove that they are parallel, and second criteria is that they are interconnected by a common point. Okay, so it has to be parallel first. Now, based on the question, if we look at the next portion, there is also a hint here about how we can compare OB and BT. So I'm going to use the hint at the second part, okay, to look for the link between OB and BT. By the way, OB was already given right at the start to be just vector B. But it is actually BT that we have no idea what is it yet. Okay, so looking for BT vector BT is actually more going to be more of a tedious working. So let's start to find BT. So to look for BT, I need to think about whether I'm using vector addition or is it ratio. In this case, OBT, I don't have a ratio yet, but that's the whole point of part 2. I'm supposed to look for the ratio later. So it seems like ratio to find BT is not the direct way. It looks like I need to go with vector addition because I have so many other ratios from other walkable lengths, okay, in part A perhaps. So if I look at B to T, perhaps I can walk from B to Q, which I have a ratio here. So don't worry about forming BQ, we can do that with ratio later. And QT, which don't worry about not having QT directly, because we also have a ratio 5:9 of PT. Okay, so BQ is 5 out of 12 of BA, and we have found BA in part A just now. And QT is 5 out of 9 of PT, which we have also found just now in part A. So if I now fit in everything that we have found from part A, okay, where BA was found to be B to O, O to A, okay, and PT was also found just now. Okay, so we just put in whatever that we have found in part A. Finally, when you simplify this whole line, you're going to get a very nice 5/16. So if you look at OB and BT, OB was just B, and BT is 5/16. Okay, so if I can simplify this by cross multiplying, I will get that BT is actually 5/16 OB. Now, why is it essential that I arrive at this form? Because we have discussed that if I can make two vectors connected by a scalar constant, I can therefore conclude that BT is parallel to OB. Okay, if they can be expressed in this form. And not only that, since they both have the alphabet B, so B is a common point. Therefore, OB they are not only parallel, but they are collinear. Okay, so you need two criteria, parallel plus common point, to fulfill the proof of collinear. Okay, so later they also ask find the ratio of OB is to BT, which we have kind of already have the ratio found, but not in the way that the question wants. So I'm going to now write it in the way that the question wants it to be in this way. OB is to BT. Okay, but they are not looking for the vector, they only need the magnitude. So if I look at just the magnitude, okay, so I can simplify, I don't need the vector anymore. So just OB is to BT, I can see as 1 is to 5 over 60, but I'm not supposed to leave it in the fraction way. So I can multiply 16 on both sides. And therefore, multiplying 16 on both sides will give me 16 to 5. So this is the answer for part B.